Okay, hey everyone. Welcome to another Common Lisp study group. Today we're going to be continuing our coverage of the Metaobject protocol specification. What we're going to be covering is kind of the final pieces of Chapter 5 related to compile file processing and a couple of other subprotocols that are mentioned in this chapter. Then we'll go into some of the more nuances that are in Chapter 6, which, from the looks of it, Chapter 6 is more of an API reference. So if there's particular questions related to anything related to the API reference, let me know. Although there is a couple of chapter things in there related to like generic function initializations that we'll be covering as well, time permitting, of course. As usual, you know, if there are questions, feel free to interrupt me. Post them online, both on the YouTube live channel as well as on Mattermost, and I will certainly get to them as quickly as I can see them. So let's begin. Let me first share my screen here with the folks that are on Hangouts, and then we'll begin. Okay, so last time, we were discussing kind of the user interface macros, which, as I mentioned, there's several of them that are mentioned in here that I wasn't sure if they existed or not, and closure them out. I was doing some digging, and it turns out that uh, the last three user interface macros that are mentioned in Section 5.4 of the spec, they're actually part of an appendix, it looks like, from Common Lisp the Language Second Edition. So I'm not entirely sure if they're part of ANSI Common Lisp specifically. Hoping some folks that are more knowledgeable in this will let me know. The three that I'm talking about are generic function, generic applet, and generic labels. So if you see, this in the explanations of generic functions in the rest of the book, just beware that they may not be available in any specific API reference. They may, at the time, they were probably considered as part of the standard, but they were rejected at some point. So I thought I'd at least bring that up. Let me see something before I begin here. This is not valid. Okay. So a couple of things in the section on compile file processing I wanted to bring up mainly is the section on there's when they're compiling these user interface macros, they tend to keep an environment that keeps track of what's currently been what up until the point that a certain file has been that's being compiled visited. They keep track of most common Lisp compilers keep track of certain bits of information to know what's already been available, especially at the macro level, so that they could display various kinds of warnings in your environment, do various performance optimizations, and so forth. The spec explicitly stated that that implementations at the time that it was designed handle there was variance in the way the implementations handled compile time environments. So they explicitly talk about how you may want to look at your specific implementation to see how it does compile file environments for compilation of macros prior to actually attempting to create certain types of portable programs. I'm not entirely sure in which case that situation will arise where you're going to end up hitting something that isn't portable across multiple implementations. But if you do encounter such a situation, be aware that the mop itself does not specify and document some of these generic function invocation things. They're implementation specific. So we covered a couple of things already in past episodes regarding def class, def method, and def generic, but I wanted to bring up a couple of things that were brought up in here regarding just some of the member variable things related to the different class meta objects during the initialization process, primarily because there's a couple things related to class meta objects and method meta objects you may want to be aware of, especially when it comes to the method meta objects and how they interact with generic functions. For one thing, the class meta objects, as you guys, most people are aware, just as a review, during the class initialization process, which is and this is kind of like if you're def classing some class, let's say point, you have no superclasses here at this point, which means it defaults to at least having standard object and so forth, if you recall. And you have, some init args, x and then accessor x. And then you had another init args point y with an accessor point y. This is kind of the canonical example I tend to go through. When this is actually created, what it does do is behind the scenes, it creates a call to the underlying MOPS implementation of ensure class, which I think is available as SBMOP, but in case it's not, I'm going to go ahead and just do a quick load of closure MOP since I just started a new Lisp REPL here. C2 MOP ensure class. And this guy takes in the name that's passed in this case it would be point, and it will go in and create a set of the variables of the class meta object structure, and this includes things like direct superclasses, where it, in this case it doesn't have any direct superclasses other than standard object and T, which you would still add in, I think, at some point, although the example in the book didn't actually say that the expansion would need to actually add those in. It's probably computed later on. But one thing regarding direct slots that I wanted to bring up, which is kind of related to the X and Y, is something that we brought up kind of in passing, but I wanted to explicitly talk about here, which is how the slot specification is converted in what's called to a property list that's called a canonicalized slot specification, which is then used as the value. So what would happen here in this case, according to what again the documentation says, is for our direct superclasses, I don't believe we need to do this, but I'll do this anyway. We pass in, I think it's going to be called standard object and then T, but I'm not sure if we need to do this ourselves or behind the scenes we'll do this. And then in direct slots, according to the macro expansion that is provided in the book, what happens with this point class is it will create a list of lists where it takes in the name. I don't know why they quote each one of these objects. I would think that you could just simply do name like this, but they actually quote it in the book. And
yeah, no reason to do that.
There's no reason to do that. That's what I thought.
All those keywords on the left too. I mean, they're self-evaluating. You don't need to do that. I'm not sure why they do that.
And what this book it says is that it would do is that for each argument in your slots list, it will create essentially, you know, the argument for the slot, and then if you have init forms or init args, it will go ahead and populate those. In our case, we don't have an init form, but according to the specification, if init form doesn't exist, um, we have two options. One, we don't need to actually provide it, or we can actually do, I think, init form nil, because it says that, yeah, its value will be false. So this is the same thing for init function. Again, if init function, um, uh, and I guess init function comes from is the case where, you know, if you recall, think if the init form has kind of like a lambda, init function will end up uh, being present in the property list to be invoked when you're trying to make an instance, so that, you know, uh, uh, the initialization function actually gets evaluated prior to the instance actually being instantiated. But it doesn't need to exist if it doesn't if init form is not present in the slot specification. Um, and then, you know, with the values of the init args list, it would then be uh, uh, the list of each init arg slot will be its own thing, and this would include things like, you know, whatever readers that we have here, which we're creating a point x. Since this is an accessor, that means we have also a writer um, in the list, which is just going to be, you know, our standard setf expander on point x, and then so forth. When we're evaluating for point y too as well, it will create another. Although I think I just messed up. This is that. Then we do another one for y. Um, Again, init form is nil. You know, our readers are y, and then we got our writers for the set of expanders. Now, one thing to note here is uh, the the init-args implementation does not actually specify anything related to um, uh, default arguments. That's a completely separate thing, as you recall. Those are direct default init args. Since we don't have any here, I'm not going to go and mention that. But the approach to actually create that default init args in a potential expansion is going to be the same as the init args and init forms that you would see in the list for each slot that's in your slot specification. Um, couple of other things that I thought were particularly interesting related to the expansions for um, the uh, the class meta object is the the part related to um, all other slot object options up here has values of properties with the same name. So, like if you had a class allocation, then allocation is directly translated and type is directly translated into the specific slot specification. Um, but in addition to that, depending upon, and this is something that I wanted to discuss, I've never seen this happen for most of the stuff that I've used in standard common Lisp, but the MOP spec explicitly says that an implementation is free to add additional properties to this canonicalized slot specification, provided these are not symbols accessible in Common Lisp user or exported by any package defined by. So if I read this correctly, it basically says that in addition to whatever is provided in standard Common Lisp, there may be additional keywords um, or additional properties that one could leverage to further customize instances in a specific Common Lisp implementation. Is that correct? Um, has
Yep.
anyone seen um, folks use that at all? Like, is there?
I think Shinmeri uses it a bit, if I recall correctly.
Interesting. Okay. Are there but that ultimately though ties you to, of course, to a specific implementation or set of implementations, then, right?
I don't think it's. I mean, it's only specific to the implementations that support mop.
Okay.
I would have to go check on that.
All right. So that's something that I thought was interesting to note, just because it was it I up until now assumed that ensure class and the class meta object kind of defined the structure of what needs to be done, but a lot of times throughout these discussions in section 5.4, from def class through def generic, they explicitly say that implementations are free to do whatever they want, but we actually have certain restrictions in terms of the relationships between arguments of the def class macro and how ensure class receives them. One of which was, of course, the only positional argument in an ensure class is the name of the class that's being instantiated. Well, the name of the class that's being defined in this case, because of we're using def class here. Everything else is, since they're keywords, they can appear in any order in any way that that the implementation sees fit, which I thought was pretty interesting. I mean, it makes sense given the fact that keyword arguments don't need to have a specified order, but the fact that they had to explicitly say that was a little okay. That makes sense, although you didn't necessarily need to spell it out. I thought it would be an explicit requirement that's implied through the signature. What is the other thing? Oh, yeah. So I'm not going to go through, every specific thing in def method and def generic and how they expand. But one thing that I wanted to bring up is, regarding def method, is something that I'm sure most folks are aware, but I will bring up anyway, which is, how does def method kind of expand into something that essentially hooks into a generic function. So how is the lookup table kind of created? Well, we kind of talked about this a little bit with respect to Closette, but I'm going to go into detail here how at least the mop specifies how it should happen.
I was wrong.
What is that?
Only an implementation can add stuff to this custom slot options to the specification.
Interesting.
But users cannot.
Users
I
cannot.
would have sworn that was different, but I guess not.
Okay. Interesting.
So yeah, you were right.
Interesting. Okay, that makes sense. That does make sense. I don't. Otherwise, it'd become a little bit complicated actually when you're trying to, add additional custom options to a given slot specification when you already have available, and we'll be discussing this a little later, options to deal with specific topics mostly related to layout that most people would like to have access to prior to something gets passed into, say, allocate instance, which will use that information. So just a quick overview of method initialization for folks who aren't familiar with how methods get initialized when you actually call def methods. So when I say method initialization, first off, I'm talking about things like if you're creating a dumb, well, a method for a particular instance. Here in the book, we have this example that was a before method that takes in some sort of position. I'll use point here since we've defined it. Some location that they have that's an equal specializer, and then what, and they have a couple of options related to whether or not the uh, game object itself is visible and so forth. Um, so when you create something like this option here, what happens is a couple of things. It's actually a three-step process, and knowing this will actually help you understand some of the warnings that often occur in the Lisp implementation of choice when you define your methods. The first thing that it does is it looks for generic function existence. So for this given move method signature, now by method signature I literally mean the name and the lambda list. Before doesn't necessarily get applied here. Again, that's related to method combination. When you're actually creating what's called the effective method that needs to be invoked. That happens later. But what happens is when this method is defined, it takes the move in your lambda list, and it goes in and it looks up the generic function related to that name in lambda list through a function called ensure generic function. Now, most implementations, what often happen at this stage is if the function does not exist, you'll get a warning. It'll create the generic function for you. It'll create a generic function instance with that information and return it from ensure generic function. What then happens is we create and let me just go ahead and do this here. We then create essentially an instance of the generic function using a function called generic function method class. What this does is it takes in the generic function instance that was returned, and it creates a almost, you could think of it like a row in that quote unquote lookup table that returns an identifier that then is associated with this particular function lookup. So you can almost think of this restriction here with all the types and that's restricting on the particular arguments becoming inputs into what could be, and this is one way I think it could be implemented. I don't know how Lisp implementations actually implemented, but one way I would think that it would do is create some sort of like hash or key of this function signature here with all the types and restrictions, and use that as a way to create an identifier. So that way, when you need to do method lookup, it just needs to hash the arguments and then hash the types of the arguments and then go in and look up what instance, what method instance you are actually asking for. Once this is done, it will go and create, a method meta object. So what would this look like? As you recall, we talked a little bit about this with respect to Closette. I'm only writing out, the method construction. I'm not actually adding additional information on this. But one way of this would be created is let me just go ahead and actually go through this so that doesn't confuse folks. We create some dumb GF here. We do ensure generic function. Of course, this is not generalized for folks looking into this, saying that, oh, you can make this a macro. I'm just, writing a potential expansion on how this would look like. And then once...
Qualifier.
What?
C2 map.
Ah, thank you. Yes, thank you. And then we do a make instance, but before we do make instance, because this is being returned and added to this method lookup, you do C2 map add method, come on, there we standard method. No. That's not what I wanted. An add method here. And direct method. I would assume direct method is the same, but I can't say for sure. But I'm going to go ahead and use that one because that looks like what it should be in this case. And we would return this guy. This takes in 2 arguments. Hold on. Let me go ahead and cut this guy out. This is the specializer that you're actually writing you're adding the method object to. And that first argument is the generic function. Again, the generic function is related to a table of potentially multiple implementations. What this does is we then take in the instance created by make instance that uses c2mop generic function method class. Yes. And this guy, as you can see here, is just taking in the generic function that we just returned, and that will create the identifier instance that you're creating an instance of the method and meta object of. And then all the rest of this method meta object is, the kind of the standard thing that you need to actually go and create the method meta object. And this includes things like the qualifiers. The qualifiers is used in order to talk about the effective method definition that's going to be computed if there are, multiple implementations of this. Some are before, some are after. It essentially applies the specific method combination that you specify in the second position here. In this case, since it's a before method, it just assumes that it's going to be the standard method combination. But if you had prog n or something like that, it'll go and, based on the specificity of the class, will go and create a new effective method that combines all those methods together. And then we have, a list of specializers here. Since we don't have any specific specializers other than the EQ specializer, it would create 2 things. Oh, sorry, it's an EQL specializer, not EQ. Thank you.
Big difference.
Yes, it is a very big difference. My apologies. And it will go in and just create this, list of I think it's called the list of specializers, and one of which is for each position, it would find the appropriate specializer associated with it and then return it. Now, in the case of the first argument, which is our point class that's being restricted, we're just doing a class specializer, so we need to just find, the class itself and return the instance of that class meta object to this for specialization. In the case of EQL specializer, I don't know if I have to use c2mop here, but there's something called, maybe, let me do that, c2mop intern EQL. Yes, all right, it is. And then we just need to pass in the argument that you would be explicitly needing for the specialization, and we'll return that. After this, the rest of this is going to look pretty easy for folks. One is the lambda list is, of course, needs to be passed in. This is going to be your signature of all the arguments without their types constraints. So this is going to be essentially visibly defaulting with some default arguments, and of course the keyword argument for color. And then, the final thing that really is, I think, particularly needed is the function itself, which is the created by some sort of function object and the lambda that's created later on, which we'll be talking about in a minute. That's the method lambda that is used to essentially construct the body it takes this body here, and it essentially constructs an anonymous function with the lexical environment, to, encapsulated in, scoped in, and it returns an object that is the return value of, I'm hoping that make method lambda is in C2 map, otherwise I would not know. Okay, cool. And if you look at, for some reason why it's not actually giving me, let's go look at the actual instance. Why is it giving me make instance? Actually, you know what? I don't think I need to actually hide this in a function object itself, because it itself is a lambda, I would think. Let me see. C2 map make method lambda. Yeah. And if you see this lambda list that's in my the function signature for make method lambda in my mini buffer, which I hope everyone can see, it's clear that it's taking in the prototype of the generic function, which we computed using ensure generic function, but it's also taking in, I never saw this before, or if I have, I don't remember it. I've never used class class prototype. I'm guessing class prototype is something related to, yeah, it is related to the mop. C2CL. Let's do this one. Okay. And this guy just takes in the class that you're using. And again, this is the return type of generic function method class. Now, what it returns is essentially the class that we've effectively are referencing right up here. If you noticed right here, so for folks who are looking at this and saying that this code can be cleaned up a little bit, yeah, certainly it can be cleaned up. I just haven't had I didn't get a chance to actually go through and actually clean it up. Once we do that, let's see here. Oops, not that one. Yeah, there we go. We would then, you know what? Give me 1 second. I'm going to go ahead and split this window the way it should have been split. That way. Seriously?
Trying to bring back the REPL.
Yep. I just don't remember.
Might be under space BB. Oh, there you go.
There you go. Yeah, it just when I do :B and I hit tab, I notice Spacemax. At least I haven't updated Spacemax in a while, so it certainly could be already been fixed. But I noticed that there's a pause as it goes and does some sort of search through all the buffers that are available, and does a partial match. All right, so this guy. The final thing that's being passed in really here is, just give me a second here. I just need to do this. Look at this. Is the Lambda expression and the environment. Now, one thing that I wanted to bring up is the Lambda expression that we're going to be returning is nothing more than, in our case, it's just going to be the Lambda, the single form that we have in there. It takes in all the arguments that we have defined up until this point, visibly p, and key color, and all it does is.
Are you sure that lambda form is quoted?
Yes, it is. Oh, wait. It doesn't have to be quoted, I don't think, but
Well, it makes a big difference if it is.
Actually, it
Unless
needs to be quoted. Never mind. It does need to be quoted because it's not being evaluated. This is actually the list that's going to be, I think, passed into funcall later on. That is actually something that needs to be quoted. So, and it's assigned later on. It shouldn't be evaluated. That's kind of why they quoted it. Now, the last argument for this guy is an environment. Now, this is something I am not entirely sure what we pass in. In fact, and if you look at the mop spec itself, it doesn't actually say what the environment argument should be. It just has a italicized environment variable in it.
I know environments aren't really portable in Common Lisp. It really depends on the implementation. It's really part of
I would
CL2 standardized it, but
I would expect that to be like an actual implementation compile time environment object.
Yeah.
Which means that you can pass in nil if you don't have any lexical environment, but that's basically the only well-defined thing you can put there.
Okay, so when I compile this this thing and I want to use a, I need to pass in the lexical environment in there. Are you saying that then I would have to scope this and wrap it in like a lambda, another lambda, and
there's actually not really any good way to do that.
Okay.
You'd need access to an implementation-defined object describing the compile time environment.
Okay.
There's a couple libraries available that do that, but that's not mop and that's not here nor there.
Okay, so that's something that I will make a note of, just so that later on, if I could look that up and figure out a way of using this, it would be really, really helpful, at least for me. But that's it. I mean, generic. This is how you would go and create essentially a method expansion for a given method when you do a method initialization. So you don't need to necessarily know about this specifically unless you're trying to do some additional adjustments. But it's certainly useful to know for folks who are going through and understanding how the mop kind of maps to existing stuff that's in the CLOS specification. Def generic does something similar. It kind of actually uses something in the same in the sense that it would call ensure generic function, look it up, how it constructs the generic function. It's kind of if it doesn't exist, it's kind of the same thing. Same way, it creates a generic function Metaobject that takes in the positional argument for def generic, which is the function name. It'll take in the lambda list and so for some of the keyword arguments that you may see in there, like argument precedence order documentation and so forth, these are just keyword arguments that are passed directly one by one to the appropriate generic function keyword argument for creating that instance. And for declarations that are in there, they're transformed into a list of declarations that become then the value of the declarations keyword argument. As you can see, methods and generic functions, you'll have similar things in there anyway, as you can tell. But I'm gonna.
I have a question.
Yeah, sure.
It might not even be related to this. Maybe it is, but it's been a while since I looked into the CLOS details. But I know that when you define a method, and like say you were to like benchmark how fast that method runs or whatever, I noticed a while ago that the first invocation of said method does some compilation process and is a lot slower than subsequent invocations. So I'm wondering when exactly that method function gets compiled, or what's the overhead for that first invocation?
I don't know.
if that's even specified by Common Lisp or Lemop or what, or if that's just an implementation detail.
From my reading of a lot of stuff related to method initializations and how things get compiled, the authors of the MOP spec, at least, and again, I haven't gone through all of Chapter 6 and D, other than some of the sections on the initialization of generic functions. I didn't see anything specific in terms of. Yeah.
Sorry, can you say that again? I'm juggling a few other things right now.
Oh, yeah, sorry. So, I noticed, like, a while ago, I never really dug into it, though, that when you define a method, and say you were to benchmark that method, the first invocation is a lot slower, so I was wondering when exactly that function is compiled, or what exactly the overhead is there.
On SBCL, so firstly, it has to do with not the method compilation itself, although that is an aspect of it, but more the compilation of the effective method, the post method combination method. That actually can't be done until you have concrete types. You can't do method combination until you know what methods to combine.
I see.
Right?
Yeah.
And you can't know what methods to combine until you know what classes the generic function's getting called with. Unless you want to exhaustively compile, all the possible combinations, but that's awful in other ways, right? And so the first time you call a generic function, SBCL compiles the effective method, the post-method combination method, which even for cases where there's only one method is still a little bit of extra wrapper code. And so because it has to do that compile, the first call's a little slower. And that's also part of the reason why you can't just remove the compiler from SBCL if you might need to call methods that you haven't already called the specializations for when you dump an image. Like, when you dump an image, SBCL has to keep the compiler around, because if you call a method, or if you call a generic function with a particular combination of types that you never called before dumping the image, it needs to be able to compile the effective method for that case.
Interesting.
And so that's why you can't just tree shake away the compiler with an SBCL. How what?
How LispWorks gets away with that, because I know they can. You can optionally remove the compiler or
They require that you ensure that you've called all of the specializations of your generic functions that you're intending to call. And I think they have tools that can do some static analysis on your code to help determine that, and can generate a whole lot of ones ahead of time, I think. But no, they would have to either that, or they include an interpreter which is capable of dealing with the extra cases.
You would also need the compiler in cases where you are redefining classes, wouldn't you?
Right, yes, but generally speaking, once you dump an image, you're not planning to redefine stuff.
Okay.
Right, usually you dump an image for the purposes of releasing an application.
Right, that's a good point.
I'm really more specifically talking about that use case. There are cases where you would dump an image just to have some libraries preloaded, and in that case, this doesn't matter for that. I'm talking specifically about application deployment, right? And wanting to be able to not include the compiler in your deployed application, because the compiler is a pretty large and expensive library to be carrying around with you if you're only using it every now and then. But the trouble basically is that because of the way generic function combinations are defined, there's basically no way to avoid needing to either do some interpretation or JIT compilation the first time you call a particular specialization of a generic function. At the very least, the first time. because you can cache it after that. But the trouble is that method combinations are allowed to generate code.
Right.
And the method combination only runs after you know the specific set of methods that you need to combine. And you can't know that until you're actually calling the generic function with concrete arguments into classes. And so you have to be able to generate code when you call the generic function.
Yeah, it makes sense.
It makes sense.
Yeah, it is very significantly slower on SBCL the first time you run it.
Yep, because SBCL pulls out the compiler, and SBCL's compiler is not particularly fast.
That's what I thought. Okay, I was just checking because yeah.
Yep.
Okay, thank you.
Sure.
So the last section of in topic related to kind of this kind of whirlwind view before we start talking about chapter 6, which really is talking about again, as I mentioned, chapter 6 is more of a API reference, is the different sub-protocols that are available related to a lot of interactions with these meta objects. They kind of just to give a quick introduction to these. They're about, I think, when I read this, they split it up into kind of 4 or 5 sub protocols. One dealing with method object initialization. Another one, there's a protocol dealing with class finalization. This is related to object functions that you would be calling on figuring out the inheritance structure and the actual effective slots and effective methods and the class precedence. You would actually go through the process of actually memoizing all that logic related to dealing with specificity and order and actually computing what methods can be called on a particular object and so forth. Then there's also stuff dealing with the instance structure, which I was particularly happy about, just because this is something related to actually being able to lay out objects in a way that you could give better information to the allocate instance. And we'll go through an example that they provided in the book that I thought was pretty useful related to that. Then finally, there's a section related to generic function invocations, and then what they call the dependent maintenance protocol, which is related to how portable meta objects that need to know about each other, how they can get information and updates when apparent in the dependency hierarchy changes or has some sort of new information that needs to be brought down to its children. To begin with, the method object initialization protocol really is kind of consisted of, from the user standpoint, of 2 methods really, which is one related to instantiating objects, and that's make instance. And let me actually bring up this. I'm going to, again, folks, I will go ahead and post this on the AFP GitHub repository once completed, so that way you guys can have this as a reference. So for meta object initialization, you have essentially 2 methods, 2 kind of functions from the UI. What I'm starting to adopt from the user interface perspective, the API perspective, and that is make instance, and the other one is reinitialize instance. Both of these are related to, of course, instantiating objects with your CLOS objects and the meta objects that those user-defined objects have taken up using the meta class directive. you can actually, with respect to this initialization protocol, create anonymous classes through the use of just calling make instance directly. It's and you don't necessarily have to specify, you know, uh, uh, a def class initiative behind the scenes. An example of this that the book gave is related to, you know, um, creating. An example of this would be like if you wanted to, you know, if param or a dummy object has in make instance with a standard class. And this is, again, you creating an anonymous class because, has I mentioned before, def class automatically has you at some point a subclass from standard class when you actually do the, uh, the def class definition when it actually gets compiled. Then you can, at this point, when you use make instance and create the anonymous class, you have all of the arguments related with standard class available to you for you to actually, instantiate. So like if you want to pass in the name, you can actually go and say foo here, and you can then see what the direct superclasses are. And these are all stuff related to the actual, uh, class meta object that we've discussed up until now. I'm not going to go through all of them that are available here. I encourage you to again go look at class meta object definition that's defined in the MOP if you want to do this kind of anonymous class kind of, if you have a use case that requires you to create anonymous classes like this. Really, if you're going to do this, I I'd rather you just go ahead and do a def class. I mean, there might be cases where you can't, like, and if you guys can, and folks who are watching this, um, uh, for folks who are watching this online on the YouTube channel, if you guys know of a use case where you may want to create anonymous classes, let me know. I couldn't think of one, but I'm just reporting that
I actually have
I used one for my game engine.
really
Yeah.
for defining game objects. I was
They're very
thinking about
useful
that, but
for
I wasn't
mixing
sure.
classes.
Say that again.
For mixin classes, because a mixin
dynamic mixins.
Yeah, a mixin is just a combination of classes. So the actual class that the user sees, or what your interface, is just an anonymous class.
I thought mixins though can still be labeled because
They
you want to
can
use
be,
them.
but if you want entirely dynamic mixins, then you need anonymous classes.
Okay.
Like if you want to be able to add and remove superclasses from your mixin at runtime freely.
Yep.
The way you do that is you make another anonymous class that has the changed set of superclasses, and then you change class from the first anonymous class to this new anonymous class.
Oh, okay, that makes sense. Okay, right. For dynamic God behavior, it would be very, very, very useful rather than you going and have to reinstantiate and do. I was thinking that at that point you would do something like you would define it and then you use either change class or redefine using class instance using class to redefine the actual instance, because at that point you'd want to, to be on the safe side, you'd want to go in and change like the layout of the object, right? Because you may want to compute some stuff a different way. But I guess in this case, you're talking about behavior specific. So if you're adding and changing behavior, you don't necessarily need to deal with data layout at all.
I was also at one point in time trying to come up with a way to make entirely anonymous classes convenient in the sense of, but really what I wanted was anonymous inner classes in the style of Java. or C#, I think. I think C# has them. Where I can have an expression that returns an instance of a class that doesn't need to be named, and only really is defined by this expression that I've just given. Right? Have you ever seen that, Rom?
Yeah, in Java, you're talking about an anonymous inner class, right?
Mm-hmm. Yep. Yeah.
Yeah.
I was trying to implement those in CL at one point. It's non-trivial, to say the least. I have some ideas about how to go about it, but I've kind of backburnered the project.
I have quite a few of those backburner projects, so I understand. Um, but related to that, you can do a lot of stuff. You can get pretty far with just doing what's it? Uh, I think like in the case of creating anonymous inner classes, because oftentimes most people who do anonymous inner classes has a form of like before lambdas they were using it as a way of returning closures essentially in Java. You can get pretty far by just creating a lexical lambda.
Yeah, I mean that's still what they do, right? Or no, well, yeah, they still simulate lambdas using anonymous inner classes. They've just created a pretty syntax for it.
Yeah, they did. Yeah, that's true. That's a good point. I think,
and really, the reason why I was doing that was because I actually find lambdas irritating sometimes for a few reasons. One, you can't so you can use a lambda to simulate an object, but you can't specialize methods to it. One. Two, it's a royal pain to access the slots.
Right. That's a good
of a lambda,
point.
unless you set it up in the interface of the lambda.
Right.
And so I wanted something that I could create as easily as a lambda and have state, but which I could specialize methods on, and which I could, in my inspector, look at the slots of really easily.
Interesting. So essentially what you'd want to do is subclass of a fun-callable standard instance and then...
Exactly. And then specialize methods on it and have explicit slots.
That's actually pretty cool. Yes,
that was the idea.
Yeah, that's a really cool... I was wondering, like, when I was looking at...
it's a royal pain to set up just right, but I'm working on it.
Oh, man, that's really cool. Okay, let's... I'm going to take a minute here to address a YouTube question that just came here from Wow. Last time we started going through the Chapter 5 and the meta objects are available already in the MOP specification and some of the nuances of those. For folks who are just joining us, if you haven't seen part 1 of our overview, I encourage you to go look at part 1 before and probably watch this afterwards. Because we're just continuing on what's available in Chapter 5. For folks who are still wondering about where some of this is available, like without getting, the MOP specification is available in its entirety at metamodular.com /CLOSMOP. I've actually in the YouTube comments, in the YouTube description of both Part 1 and Part 2, I've point you guys to that MOP specification URL. If you actually go and Google the MOP one, I think some dude by the name of Hexstream created something. Don't use that one. Use this, although this is not as pretty as that one. This is probably more thorough and more. It actually, I think, is a direct translation of the MOP specification. Thanks to Robert Strand. So there's no opinions, so to speak, that are on this particular version of the MOP spec. So I encourage you guys to look at it. Let me see if there are other questions that might be popping up here. No. All right, cool. Before we go on, folks on the channel, are there questions from some of the other people? We've been discussing quite a bit here. Richie, Mike. Okay, cool. Let's just go on then. So the next protocol that we're going to be talking about, and this is kind of an important one, this is related to how do we finalize classes. So when you do a make instance of a class, um, uh, of course, it will first take the class declaration. It will compute its class precedence list using compute class precedence list. It will compute effective slots using compute slots. These will return, as we mentioned before, not the canonicalized slot definitions, but rather the effective slot definitions classes. You could see the differences by looking at the definitions of those two classes in the Metaobject spec. Also, for class finalization, um, it deals with the computing the full set of initialization arguments, which is including the calling the function compute default init args. This guy is against memoized. All these functions that I'm mentioning are computed once and then just returned every time.
Yeah, and if you need to inspect the class, you don't have to call make instance. That's an implicit finalization. You can actually call. There's a function in ensure finalized. If you need to finalize it to inspect it further,
right,
without creating a dummy instance.
Right. So for the finalization protocol itself, the process is called through a generic function called finalize inheritance. At least according to the book, I'm not entirely sure if this is the actual one that implementations do. I'm assuming it is. C2 mop certainly uses it in terms of its way of doing it. So if you look at C2 mop here for closure mop, and you do finalize inheritance.
Regardez là aussi. Regardez, ça s'égoutte pas. Je fais quoi? Je fais quoi, mais ce tout? Regardez ça. Ça monte pas au tuyau.
Elijah?
Elijah.
Yep.
You okay there, buddy?
Really, you guys can hear that?
Yes.
Yeah.
Huh. That is amusing. Okay, I'll have to work on that.
I was like, okay. I was like, what's going on? Why am I hearing French?
Just ignore me. I'll mute myself on Hangouts properly now.
Okay. All right. Finalize inheritance, as you can see here, in the mini buffer, is really just taking any class meta object that it will do, and it will go through this process. As Michael Fiano rightfully mentioned, that you could explicitly call this finalize inheritance to finalize your class declarations.
I haven't actually used that before. I was talking about the, I think it's called ensure finalized, to finalize the whole class.
Yeah, you can use ensure finalize. I think when you do, I think ensure class actually. Oh, here it is.
Yeah, that one.
Yeah, ensure. I think ensure finalize, if I'm not mistaken, and I have to go into. If you guys give me a second. I think ensure finalized actually calls finalize inheritance behind the scenes if it hasn't been finalized at all. Let's see here.
More than likely.
You know, I see ensure class using class. I see ensure generic function in the spec, but I don't see ensure finalized in here.
Interesting.
This is, of course, in the MOP spec has defined by chapter 6 of the book. Usually, I would assume that since it looked like everything was in alphabetical order, right after I see ensure class using class, I would see ensure finalized, but apparently it's not there.
Oh, it's not part of the map.
Yeah.
It's a utility function added by closure map.
Sweet. All right. Thank you. That's kind of. I wasn't sure. I was like, this would be really really embarrassing if my mop book didn't have stuff that's in the mop spec. All right. Um. So yeah, you can call finalize inheritance directly, um, if you wanted to. Uh, in fact, in some cases, it might actually happen. One particular case, as it is brought up in the book, is when the class is previously finalized. Um, it would be called explicitly because behind the scenes, what it would do is it will do a lookup, see if the class has been finalized. If it's been finalized, then it will make a function call to make instances obsolete, which would then um, potentially in other cases, as we would talk later when we talk about the dependency protocol. It would notify them to say that there have been changes and you may have to update them accordingly. The one question that I have here is related to forward reference classes, because if you have a class that's subclass of forward reference class and you're trying to make an instance of that class, I would assume that during finalized inheritance it would follow this behavior where it triggers a signal, but I'm not sure. We could try that out. Let's see. Let's do this dummy thing. Let's say, I would assume that behind the scenes I could do 3D point subclass 2D point. 2D point does not exist as in my current Lisp image, as folks will know. I only have Z, and it args point Z accessor. And if I compile this, and I would assume that if I tried to make an instance here, it would throw up an error because of finalized instance. Inheritance would then recognize that 2D point doesn't exist.
I believe it'll throw up an error for another reason.
Okay. While computing the class, yep. That's what I assumed. That's what I would have expected. What reason would you have thought it would throw up an error for?
Oh well, it didn't even get to that chance yet.
Yeah.
Or that, but my the reason why is because you're calling it init args plurally.
Ooh. Thank you.
For your other class too that we defined earlier.
Oh, this is just so bad. Okay, I need to stop doing this. I am. But this is the same thing. It's a forward reference class. Forward reference class can't be instantiated, so finalized inheritance will throw up a trigger, and so any subclass of that forward reference class will also get the same error. So obviously, for folks who are who looked at this and said, well, why didn't it complain when you subclassed it? Well, that's because behind the scenes, when you call def class and it does a call to ensure class, that 2D point, since it doesn't exist, it becomes, I think, a subclass of forward reference class, and the object that gets constructed by make instance, well, the class meta object, when you do ensure class, that the class meta object that gets returned by ensure class will have that forward reference there. So you might be wondering then, well, what would happen if 2D point gets defined? Well, at that point, and we'll talk about this, this is related to the protocol that's, the order in which they did this is kind of weird, so I'm kind of jumping around between this because they're dependent with each other. The dependent maintenance protocol would then be used to essentially implicitly provide a relationship between 2D point and 3D point. And when 2D point gets defined, what ends up happening is 3D point gets notified and its class object we'll go through finalize inheritance again, and compute class precedence list will then be computed, and everything else will get memoized accordingly correctly. At this point, when it got defined, the compute class precedence list did not get invoked. And because compute class precedence list did not get invoked, you did not get an error. But when you did make a call to make instance, it will. And that's why you will get the error later on. This is something that I found a little odd when I was first getting into this, but it makes sense now that I'm getting more and more into how the mop actually works, because this allows you to dynamically create particular classes at the appropriate juncture when you need them. So for folks coming in and looking at this and says, oh, this is kind of screwy, I wish it would do it a little earlier, that's a bit more of an eager approach to actually doing class definition than what this approach does. Thought I'd mention that related to the dependent maintenance protocol.
Everything's in the interest of live coding, common Lisp.
Right. Exactly.
It can't be so static.
It can't be so static, exactly. The instance structure protocol is an odd one. I'm going to go ahead and go through this example because this would require a little bit more discussion. But I'm going to first explain the protocol and then go through an example. So we kind of mentioned through a couple of episodes this idea that you can actually talk through and deal with allocating particular, storage objects within Common Lisp using the function allocate instance. Now, at the lowest levels, the allocator itself is not accessible. That means you cannot go and change how the object is going to get allocated at runtime or at compile time. That's for good reason. That's related to how, what? The stream cut out and I never came back. Hold on 1 second. Part 1, the stream did not cut out. I think that was 2 weeks ago. Wow, I think related to the cutout stream, that was related to Jitsi giving us some technical problems. Last week, as far as I could tell, the Hangout stream did not get cut out. So,
nope.
So please watch the stream on Chapter 5, which is the actual previous stream before this one, to get more information about the core one. The Jitsi one, honestly, it was the last talk related to Metaobject protocol design. That is, while useful in understanding the meta-objects related to generic functions and methods and meta-objects, since we're kind of going through that kind of information already too as well as we go through the rest of the meta-objects with relation to how it's specifically implemented in CLOS, it's useful from an information perspective, but it's not useful from if you want to use, say, closure mop, because we're going through that right now to say what's available. I hope that makes sense. I'm not, for folks who are watching in, I'm not discouraging you not to watch that talk, but for various reasons, that talk went through a couple of issues before when it got recorded. I may at one point actually go and re-record that particular talk and replace it. But for the time being, last week and this week kind of is a good replacement for that particular talk because we're going through some of the same material. So getting back to instance structure protocol, because you can't actually control this allocation at that level, what can you do? Well, one of the nice things that Common Lisp has provided is this notion of being able to implement behavior regarding those slot access functions using slot value in its setf expander. There are a couple of particular ones that you may want to be aware of that's in the a very nice table in the map spec, and those are slot bound p, slot make unbound, the slot value itself, and its setf expander. Set slot value. These have equivalents in the generic function world. So, like for example, slot bound p, what it does is it internally calls slot bound p using class, and all these other functions have the same thing. So slot make unbound. Well, the generic function for that is slot make unbound using class. One of the nice things about the excuse me. One of the nice things about the mop that I really have enjoyed while going through this has been the fact that the names are so consistently named. Like, the API is so consistent in terms of how it does naming schemes that you can literally pick up one of the things, and more than likely, the generic function related to that for the mop for you to do stuff with it is either dash using class or dash class, which makes looking up a particular function in the mop specification kind of a joy in terms of, I can quickly find it and actually do my thing. Why am I bringing up slot access functions and this API? Well, when you're dealing with writing portable programs, these are the only kind of mechanisms that would give you slot access and dealing with slot access. And in particular, you can use this with the allocation information that you could get on a slot Metaobject to kind of manipulate how for a given class declaration, how at instantiation time those slots get ordered. This is particularly useful when you're ending up using like compute slots to determine the slot definitions and so forth, because that behind the scenes calls the location generic function for the slot definition, and use that to actually go and compute how to the instantiation pieces that would then ultimately go down to allocate instance to create an instance of that object. I'm not saying that it's guaranteed, because I don't believe that it's
I have like pretty strong opinions on using slot value that you probably don't want to hear.
I'd love to hear them.
Well, I try to limit using slot value and thus with slots as much as I can, because like it sort of interrupts the user's like ability to intercept that. Like if it was an actual accessor that you were using, sure, they could customize that with like an around method or whatnot. But by accessing the slots directly, like the user can't really modify the behavior of your program.
Oh, certainly, and I think that's something that I was looking into when I was. I'm still going through this before I record this to figure out how to do encapsulation, like proper encapsulation from C++. In Java, like how they do encapsulation. I was trying to figure out how you would do that so that when somebody calls slot value on an object that is a subclass of encapsulated class, it would throw an error saying you don't have access to this. You need to use the actual API to actually go in and grab that information. So the example that they go through for this is something called they call it ordered class. This is a class that they defined for the use case where you want to implement a new class with a new class option called slot order, which is used to control the allocation of slot locations. So we can create this class called ordered class now that is a subclass of C2mop standard class. This guy would introduce a new, essentially a new argument called slot order, which init form is just, the empty value. It has the init arg for a slot order here. And that slot order is used primarily so that you could determine when you're computing the effective slot definitions, how should you go and then, create and compute call next method. So we'll see some of the implementation that would be associated with that. The reader that we've created here is, since this is associated with the class Metaobject, usually you'd want to follow the same naming schemes that that the mop kind of adopted for each of the Metaobjects that they've defined. So here we're creating something called, oops, this is not a list. This should be a list of this. Something called class slot order that will give us the number that we've defined, or the list that we've defined. Now, how would this be used? Well, when you're computing the slot definitions now, for folks who are watching, every time you're trying to do an override and you're reading the book, the AMOP, just remember that to make it portable enough, you should use C2mop's API. So when we're trying to override C2mops, let's go ahead and at least this is kind of the practice I use. I never use the :use in a package or use package. It's easier to know the symbols by having it connected to the package that it's associated with.
That's a very good practice, yeah.
So when we're computing the effective slot definitions now, we're creating a restriction on the C2mop compute slot class, which will take in the order that for a given slot. Class slot order, and class and what we would do is we sort the list that we've. Wait, why is copy list not? Why copy list not showing up in my mini buffer? Okay. And we sort it based on the lambda function that we're providing, where the position of a given slot definition
Yeah, don't use sharp sign quote for lambda.
Yeah,
It's technically legal, but it won't be legal in certain contexts, and it could actually do the wrong thing in other contexts. So it's just best to use the lambda rather than the function.
I'm just so used to doing it that way because I think Practical Common Lisp uses it everywhere, and I just adopted it for years. That it's I'm trying to change it so that it's
For instance, it's not even valid in the report part of a defined condition.
Interesting. Slot definition and based on the order. Okay. So what is this this function doing? This is essentially creating a new list for our ordered class that, based on the position that it's in the list of class slot order, it will go ahead and sort the effective slots so that you would always get them in the order in which they've been laid out in the class slot order. So how would this? Let me go in and show an example of this. Let's go back to what we had before on our point. This time we're going to redefine it. We're going to have two things here. Point x. And again, this is a 2D point, so now we would create a meta class here. We'll say that this is on meta class, ordered class, which will give us access to the keyword argument that we just created, slot order, and we can actually specify x and y, and this is the order in which the slots themselves will be able to they will be actually ordered when the any point instance is instantiated. So if we got what? One second, did I forget to do that? Change class int. Oh, sorry. That means this guy. One second. It's because of the fact that I defined class earlier. The point class earlier. Okay. Let's go ahead and do this again. Do this. Do this. Do this. Standard class object was. Oh, damn it. I forgot to add validate.
Oh, that method everybody forgets to write.
C2 mop validate superclass restricted on oh, what was it? Oh, no. That method. I was like, what the hell is it doing? Validate superclass. What is it? Class is restricted on ordered class, and superclass is standard class. Let's return true. Okay, so hopefully now, okay. So now that we have this, we can compute functions, like for example, we can define functions or methods that are restricted on this guy. Let's say, we compute functions based on distance. We could then use I think it's called, and I'll show you this in a second here. I don't want to give up all of the fun. You can use, to access the points method, you could actually use, I think a function called standard instance access on the instance in the location, and it behind the scenes, because we use slot order to compute the effective slot order, you can actually access it based on its index, its high level, its actual slot location index, instead of calling slot value or anything like that on top of that. So in this case here, we're just defining, a simple,
I'm trying to think one that would actually be useful.
What?
I'm trying to think one that would actually be useful.
Well, one thing that I was thinking of is if you wanted to use this to, say, create a graphics object that will go into the graphics card. This is this would be a totally good use case for it, because then it behind the scenes will be able to map. You could write a mapper between when it's in host memory and device memory, and you can use this to create a simple lookup between how it's going to be represented on the graphics card and how it's actually in Lisp memory. At least that's an idea that I was playing around with in my head related to it. I don't know if it's you might think of other cases, but who knows. Okay, So we do
So
this.
the man had distance.
Now we have distance, and we can make an instance of point where, and I just forgot that I should have actually provided an init arg here. I hope this doesn't. Init arg. Okay. Point x and point y. Don't complain. Good. Point x is 3. Point y is 4. Did I? And why is this the square root of divided by 2? The example in the book, for some reason, is doing this, which is the average distance, I guess. So we can do this. And you can see that it's taking 9 plus 16. I'm going to do this. This looks weird for me. I'm just going to go ahead and take out this. It should be, distance should be really doing differences, but I'm not providing differences between the 2 points right now. Let's see this. Yeah, that would work. All right. So you can see that this guy is taking in the order. So x is now 0, y is now 1. We're grabbing the instance locations of them, grabbing the particular values and computing it. And we just went over. So I'm going to end this stream today. We're going to finish off Chapter 5, Fun-Callable Instances, as well as the generic function invocation. And we'll get started on, it'll be a good segue into the last topic, which is in Chapter 6, other than the API reference, on just complete initialization of generic functions, meta-objects, slot definitions, and so forth. Wow, to answer your question, yes, I am planning on doing a stream where I am utilizing the mop with some better examples. I've kind of been planning it out right now. It's just getting there's stuff in the mop that, the book describes, but the API is kind of different. That's I've been kind of working through. But stay tuned. I will post on Mattermost when I have some more of those. Are there any other questions from folks on the stream? If not, thank you for joining me. I'll see you guys next week. What?
Question.
Yes.
Can you hear me?
Yes, I can.
Yep. Question is, would it be possible as a practical exercise to take one of Shin Mera's projects where he uses massive use of the mop and kind of go through that and analyze it with respect to what we've done?
Yes, I think that would be a great idea. I think, in fact, there was another suggestion that you brought up, Elijah, related to something that Robert Strand brought up that I was hoping that we'd get a chance to actually go through to as well. So there's plenty of cases out there where we can go through and do some code reviews and try out some things ourselves. If you have all those ideas, post them on Mattermost because I want to keep a record of them because otherwise I'll forget. This way, the CL study group records will be there, and we can get through them as we, time permit, as we go through more and more of the MOP stuff. Again, just a reminder for folks, we will be taking a short break at the end of March related to the MOP, and just so that we can go through the game programming series that we've been talking about. If there are other talks prior that you want to take precedence before we do more MOP case studies, let me know. I'd certainly be willing to put those on the list. And as usual, for folks who are in the Atlanta area and you want to give a talk, please contact me or Judd Taylor with your talk ideas, and we'll get you on the schedule to present at our monthly AFP meetings. So until, if there aren't any more questions, until next week, I'll talk to you guys later.
Bye then.
Bye.